chapter light, okay, which is very important chapter from your board perspective. And it is also important from the perspective that if the students are aspiring to do engineering or need medical or engineering, then this chapter as it is repeated in your 12th class. So very important chapter. And as I said that what I will be covering is basically image formation by mirror, and try to explain you the concept of a virtual image and a real image. Okay. So before I proceed, let me show you something from internet. Okay. Uh, and that is something freely available on the internet. Even if you guys wish, you can go and see it. Okay. So you can see my screen. this this is a plane mirror, and this is object one. And behind this, we see the virtual image of object one. And everyone is aware of it because plane mirror is something which is always at our home, and you always see the image in the plane mirror. Okay. And you all knows what are the characteristic of the plane mirror image. The image found by the plane mirror just a second. The image found by the plane mirror is virtual, it's erect, it's same size as the object, and is located as far behind the mirror as the object is in the front of the mirror, and it is laterally inverted. And laterally inverted means your right hand becomes your
Excuse me,
left
sir.
hand. Hello.
Yes, sir. Sir, how long is the session?
40 minutes.
Okay, sir. Sorry, sir.
Okay, no problem. So this is anything about plane mirror is like everyone knows about it. We know that the image is erect. We know the when we are standing in the front of the mirror, our height and the height of the image is exactly equal. We also can intuitively feel that the distance of the image from the mirror is same as the distance at which we are standing in front of the mirror. Okay. And we know that if you put any object in front of it, then the left becomes right and the right becomes left. Okay, someone is trying to share the screen. Please don't do it. So otherwise everyone will be disturbed here. Okay. The only thing is, what does virtual image means? And what is the difference between a virtual image and a real image? This is something I'll try to explain you at the end of the class. So I hope that everyone understands what is the image formation by a plane mirror. It's virtual. You have to remember it. It's erect. Everyone knows it. The size of the image is same as the size of the object. Everyone knows it. The distance of the image from the mirror is same as the distance of the object from the mirror. Everyone knows it. The image formed by the plane mirror is laterally inverted. That is, right becomes left and left becomes right. Everyone knows it. Everyone has felt it. Okay. So there is nothing to explain here. The only thing is, why is this image called virtual? This is something we'll discuss in the class. Next is mirror. And we talk about, apart from plane mirror, we'll talk about spherical mirror. Okay. So when I talk about spherical mirror, how do we get a spherical mirror? So so let's take a sphere, hollow sphere, glass sphere, and let's cut it. I think my pen is not working. Just a second. I'll again start the session. Just a second. Okay, so it's working now. So now what we do is we cut this spherical part. So this is the curved surface of the sphere we have it. Okay. Now we have two options. Either we polish this surface from here. We polish this surface from here. So we do the hashing here. So reflection will happen from this side. Reflection will happen from this side. Or what we do is we polish this outer surface. We polish this outer surface. So reflection will happen from this surface. Okay. So either the reflection happens from the inner surface or the reflection happens from the outer surface. If the reflection happens from the inner surface, we call this mirror as concave mirror. And if the reflection happens from the outer surface, we call this mirror as a convex mirror. Okay, so this is a quick revision session. I'll not discuss the definition of each and everything. I'll discuss the formation of image by this concave mirror and convex mirror. And then we'll try to see what is the real image and what is a virtual image. So let's take this example of concave mirror. Okay. Because the reflection is happening from the inner surface, this is a concave mirror. An object is placed in the front of the concave mirror. And there are few rays which are starting from the object, which after reflection is meeting somewhere here. And this is the position of the real image formed by the concave mirror. This is something, you just visualize it. I'll explain you what is this. And if I take the convex mirror like this, what you see here is the image is formed behind the mirror. And this image is known as virtual image. Okay. So I have three examples in front of you. The image formed by the plane mirror, which everyone experiences in the daily life. The image formed by the convex mirror, and the image formed by the convex mirror. So this is written as real image. Here, if you see here, it's written as real image. Here, this is written as virtual image. And here also, this is written as virtual image. So all the three diagrams are in front of you, from the plane mirror, from the convex mirror, and from the concave mirror. Okay. So look carefully at the ray diagram of all the three mirrors again. This is concave mirror, this is convex mirror, and this is plane mirror. From the plane mirror, we are getting virtual image. For the convex mirror, we are getting virtual image. And for the concave mirror, we are getting real image. Can anyone tell me, how do we identify what is real and what is virtual? You can unmute yourself, give the answer, and again mute yourself. Just by looking at the three images, this is real image, this is virtual image, and this is virtual image. What is the difference between real image and virtual image?
Real image is formed in front of the mirror and virtual image is formed behind the mirror.
Okay, so one difference which we can observe here is, just a second. One difference which you observe here is, uh, okay, so what we observe, I'm not saying what it is real and virtual. What we observe is, from the ray diagrams, we observe that real image is in the front of the mirror and virtual image is behind the mirror. Okay. Technically, any other definition which you see from the students can turn the video off. So for that, it will make the quality better. Streaming quality will be better if you switch off your video, right? Okay. Any other difference which you see in the ray diagram for the virtual
Sir,
image?
what virtual image is always erect and real image is inverted.
Okay. Another difference which the students have observed is real image is inverted and virtual image is erect. Okay. Any other difference? Okay. I'll again show the ray diagrams. I'll request everyone to turn their video off for better quality. Listen. Oh, sorry. See carefully the diagrams. This diagram, see carefully the image. See carefully the image portion. And see carefully the image portion. Can someone now identify what is the difference between the real image and the virtual image? If I move the object, you can see the movement of the image. I'll show this movement of the object and the image in the class. I'll explain this, okay? But this is how the image is formed. So this is how the image is formed. Can you notice some difference in the rays? Any difference in the rays for the virtual image and the real image? Any difference? Okay, so I'll tell you the main difference between the real image and the virtual image. Real image is formed by actual meeting of reflected rays, whereas virtual image appears where the appears from where the reflected rays appears to diverge. Okay, this is the fundamental difference between the real image and the virtual image. When you actually see the rays converging or diverging at any given point, then that is real. And when the rays are not there, actually it's just dotted lines. This incident ray is coming at this point and is getting reflected here. It's not going behind the mirror. Okay? Or this ray which is traveling on the straight line is again reflected back here. Then these are not. Similarly, you see here. This incident ray was reflected back. This incident ray is reflected. None of the rays going behind the mirror. None of the reflected rays actually intersecting. These are just dotted lines which are extended back. Okay. And if you see here, you actually see the reflected ray meeting at this point. You actually see the reflected ray meeting at this point. So is the difference between the real image and virtual image clear to everyone?
Yes, sir.
And one point which a student mentioned in the chat, and he's very right, that when you are doing an experiment, okay, when you don't see the rays moving from the object and the image, then how do you differentiate with the real image and the virtual image? Then the difference is, what happens is, real image is always formed on the screen. You need a screen on which the image will be formed, and then only you can see the real image on the screen. Okay. Whereas a virtual image is always an abstract concept. You cannot take it on the screen. Like when you're standing on the front of the mirror, you see your image behind the mirror, but you cannot place a screen anywhere where you can see the image coming on the screen. Okay. I don't know if anyone has joined late in the class, and if he has missed something, what I can do is I can share the recording of whatever you have missed it. Okay. So 2 points are very much clear. For the real image, the rays are actually intersecting. For the virtual image, they just appear, like in the case of the plane mirror. Okay. So this is something like I'm taking a beam of light falling on a plane mirror, and we see it's reflected back as it is. Instead of this, if I take a point source, and if I see this extended rays, so the incident ray are there and they are reflected back. And these orange rays which is extended backward is just the extended rays. And this is the object and this is the image. In the plane mirror, the distance of the object from the mirror is the same as the distance of the image from the mirror. What we see here is these orange, this is the source. The light is emitting from the source, but these reflected rays goes back. They never go behind the mirror. These are just the extended rays which are not there. Okay. And this is the position someone looking at the mirror. If a man is standing here, this blue color, if he comes here, he cannot see the image. You also know, when you're standing oblique to the mirror, sometimes you can see the image of the person who's standing in front of the mirror. Sometimes you cannot see. Okay. If you go behind the mirror, you can never see the image. To see the image, you have to be always in the front of the mirror. That is just who can see whom in the mirror. If you want to see the image, the reflected ray should reach your eyes so that you can see the image. Is this clear? So anyway, that was okay. I will again come back to our convex mirror and concave mirror. So what do you see here? How do I form the image? How do I form the image? So to form the image, we need at least 2 rays to intersect. So we should know what are the laws of the reflection so that we can form the image. Laws of reflection. I know that everyone knows what are the laws of reflection. So the first law of reflection is angle of incident is equal to angle of reflection. Everyone knows this law. Can someone tell me what is angle of incidence and what is angle of reflection? What is angle of incidence and what is angle of reflection? So if I draw this plane mirror, okay, if I draw this plane mirror and if I draw a line which is perpendicular to the mirror, if I draw a line which is perpendicular to the mirror, then I say this line is normal to the mirror. Angle of incidence is not the original line. Original line is incident ray. So if this is my incident ray, then this is my reflected ray. Okay. If this is incident ray and this is reflected ray, then the angle which the incident ray makes with the normal is known as angle of incidence, and the angle which the reflected ray makes with the normal is known as reflected ray, reflection, angle of reflection. So I is equal to R. Angle I is equal to angle R. Okay. Angle of incidence is equal to angle of reflection. And second is this incident ray, this normal, and the reflected ray. This is incident ray. This is normal, and this is reflected ray. Will always lie in a plane. They cannot be outside the plane. Otherwise, it will be the diffusion. It will not be reflection. It will be diffusion. So angle of incident ray, reflected ray, and the normal lie in the same plane. My question is, second law is what? Incident ray, normal, and reflected ray lie in the same plane. They are in the same plane. So my question is, for the spherical mirrors, okay, for the spherical mirrors, how do I define angle of incidence and angle of reflection? Let's say this is incident ray. This is incident ray. How do I define angle of incidence and angle of reflection? For that, I need the normal. Okay. So how do I find the normal for an sphere? If you guys don't know, I'll just tell you how to find the normal. This spherical mirror is a part of the sphere. This spherical mirror is a part of the sphere from which we cut it, right? This is the center of the sphere. Okay. So if I join the center, if I join this center to the center of this mirror, this is pole. Okay. If you join this to pole and this center, then any line joining the center to point on the sphere is the normal to the sphere. These lines are normal to the sphere. So how do we find out the normal? Any point on the surface of the sphere you just join it to the center of the circle and you get the normal. And you get the normal. And now you measure this angle I. Then this is the reflected ray. I is equal to R. And this line, which I'm joining from the pole is actually the point, which is a geometrical center of the mirror. Geometrical center of the mirror. That is whatever mirror we have cut out of the sphere. It will have some center point, na? It will have some center. That is known as pole. And this center of the mirror, we join this line. Then this line is known as principal axis. You are right. This is known as principal axis. And this is angle I is equal to angle R. So this is how we find out the normal. This is how we find out the normal. Now, the first rule is, how do we form the reflected ray? How do we form the image? We need at least two rays to form the image. The first rule is, any ray which is parallel to the principal axis after reflection will pass through the focus. Everyone knows the definition of the focus, I assume. Okay. I assume everyone knows the definition of the focus. So any ray which is parallel to the principal axis will pass through the focus. So see the ray which is coming parallel to the principal axis. See the ray which will start from here and come parallel to the principal axis. You will see that that ray will pass through the focus. Okay. So this top ray which emerged here, which was parallel to the principal axis, you can see here, it's passing through this point focus. Okay. So first ray which I can draw is if this is my center of curvature and this is focus, then I can say that ray which is parallel to the principal axis will pass through the focus. This is first ray which I can draw. Second ray is if the ray hits the pole, then it will be symmetrically reflected here. This is angle of incidence and this is angle of reflection. I is equal to R. Here this will be the normal, but I have not drawn the normal. So if you see the second ray here, which will be hitting the pole, this ray which is hitting the pole is symmetrically reflected about the principal axis. So this is the second ray which you can use to draw the image. And the last is any ray which passes through the focus. Any ray which passes through the focus after reflection will become parallel to the principal axis. So if you see this ray, the third ray, which is passing through the focus after reflection is becoming parallel to the principal axis. So you can use any of the ray, any of the two rays to form the image. You can use any of the two rays to form the image. Either the rays parallel to the principal axis, then after reflection it pass through the focus, or the rays passing through the focus, then after reflection it will become parallel to the principal axis, and any ray which hits the pole is symmetrically reflected from the pole. Okay. And because all these three rays are actually intersecting at this point, we see that the image formed is the real image. This is something happening for the concave mirror. What will happen for the convex mirror? If I come for the convex mirror like this, any ray which is parallel to the principal axis will reflect back like this. And if you're standing here and seeing this ray, it will appear to us that this ray is coming from the focus. It is appearing to us that this ray is coming from this point. This is originating from this point. But this ray has never reached that point. This ray has never originated from there. This ray is actually coming from here. So because this is just my extended ray, this is my extended ray, it is never there. So the image which will form will be actually imaginary. Any ray which will hit the pole like this will again go like this, symmetrically. So if I extend here, it will meet here. So this is where the image will be formed of this object. Yes, virtual. So this is virtual image. So you see here, the ray which was parallel to the principal axis was reflected. It appears that it is coming from the focus. Any ray which hits the pole is reflected here. Okay. And any ray, please don't, Josefa, Zahid, whoever is, don't use the board. It's disturbing. And any ray which will appear to pass through the focus will become parallel to the principal axis. Okay, will become parallel to the principal axis. Is this clear to everyone? So what we see here is now I don't know, someone is written on my screen and I cannot erase it. So is this clear? Can you see the image formation by the concave mirror and the convex mirror now? And do you understand what is the difference in the virtual image and real image? Any doubt here?
Yes, sir.
This is suppose which was I was supposed to cover in today's class. And in the next coming sessions, I'll go into details of some of the ray diagram and I'll replicate this entire thing for the lens and explain you how the things exactly work for the lens also. There also will get the same real image and the virtual image, same incident ray, and there will be a refracted ray, not reflected ray. Instead of reflected, we'll get refracted ray. So what we are getting here is, we are getting reflected rays here. For the lens, you'll get refracted rays, but we'll get same thing. We'll get a real image, we'll get a virtual image. And again, you will clearly see the difference that the real image will be formed by the actual meeting of the refracted rays, where the virtual image will be something from where we'll see that the rays appears to come from. The rays are actually not there. The rays are actually not there. In a ray diagram, it will always be like kya bolte hain? Extended rays. It will always be like extended rays. Okay. So, like the ray passing through focus becomes parallel to the principal axis. Here, it appears to go this direction. It is never there. Okay, this last ray diagram which I missed, we can draw this diagram. That if the ray passes through center of curvature, because it is along the normal, so angle of incidence is 0. So it will be again reflected back in the same direction. Why? Because here angle of incidence is 0. What is happening here? Okay, I'll explain in the next class what is the difference between reflected and refracted rays, because that's a different topic. Okay, here you see here, your incident ray is here. This is the center of curvature. So same line is the normal. What is the definition of the normal? You join the center of curvature to the point. So if my incident ray is passing through this point, that means the angle of the incident ray is 0 with the normal. So reflected ray will also make the angle 0. So it will reflect in the same direction. Okay. So this is how, this is all what was intended to cover in today's class, that how we can form the ray diagram. Oh, with the help of the ray diagram, we can form the images with the, no, it's not hard actually. If you understand this, then it will be very easy. So in the next class, when I'll take the lens now, you'll find it very easy actually. And if you guys have any doubt in today's lecture, you can, in the respective group, you can post your doubts. And I will be sharing the notes of this lecture as well as the entire lecture. And I'll be giving some questions and then the answers to the questions so that you can practice them. Okay. And you can always get in touch with me on the WhatsApp group with your doubts. And very soon I'll take the next class and I'll announce in the group only about the next timing of the class. Okay. I'll give the recording. Anyone who has missed the class, I'll share the recording with them. I'll let everyone know when will the next class. Very soon.
Thank you, sir.
Okay. Bye-bye.
Thank you, sir.
Bye-bye, everyone. Have a nice day. Good night.
Thank you, sir. Good night.